Now that we went through a brief introduction to atmospheric circulation and hydrologic cycle, let's get a little bit into the ocean. Again, this is a very basic introductory course, so we're not getting into any sort of detail here. I have separate courses, complete courses on tropical dynamics, ocean and atmosphere. I have ocean atmosphere dynamics course. And I have oceanography course where we get into a few more details of various aspects. So here, keeping with the simple introduction, let's see what are the critical things that are important for deriving ocean currents given the winds. You know that the ocean is mostly forced from the surface by winds, the rainfall and evaporation, and by the heating and cooling, unlike the atmosphere, which as we saw is driven by some of the short wave that it absorbs, some 23%, mostly from the bottom, the radiation heating the surface and then forcing the atmosphere from the warm surface, the ocean is forced a little bit from geothermal heating at the bottoms, but that's not such a significant part of it. The biggest difference, let's say, between the atmosphere and the ocean, as we said before, is that the atmosphere has no boundaries. So trade winds, they exist across the globe. Westerlies go around the world, polar easterlies, and so on and so forth, but the oceans have boundaries. So it turns out that the two important things are that the ocean has boundaries, and Coriolis actually increases from the equator towards the poles. This makes a huge difference for these are the determining factors for why the ocean currents are the way they are. So let's start with this simple schematic here showing our northeasterly and southeasterly trades and mid-latitude westerlies. So the trades are going to try to drag the ocean westward, and basically winds begin to stir the surface, and then the ocean surface begins to have waves, which gives it friction, and the atmosphere can then grab the ocean and drag it along by friction. And when the water hits the west coast, it can go south or it can go north. It turns out that because of the Coriolis effect, it ends up going north, and the other thing that the ocean is doing is putting circulation or vorticity into the ocean. So you can see that the westerlies are pushing the ocean eastward while the trades are pushing it westward. So you think it is intuitive that the gyre here, the subtropical gyre, is going clockwise, which it is, but what is not obvious here is whether the northward current here is exactly the same as the southward current here. Turns out that there are very massive differences between the western boundary current and the eastern boundary current. Okay, we won't get into the details, but I have lectures elsewhere where you can look up the details if you wish. So basically the ocean is trying to balance two things. One, remember that Coriolis increases with latitude, which means when trades drag the ocean this way, ocean currents are deflected to the right, so northward in these latitudes, and while westerlies are dragging the ocean this way, Coriolis is pushing to the rightward, so it's being pushed southward here. But Coriolis is larger here than here, so less water is being pushed northward here than being pushed southward here. So there is a net push of water southward because of the Coriolis being larger here, which means there is a net southward transport being created by this trade wind and westerly combination. So water has to be taken back north, which obviously can happen here. But the other thing that is happening, which is a little bit more complicated, is that winds have what are called wind stress curls. So if you curl your fingers around the trade winds going northeastward and mid-latitude westerlies going westward, then you create this finger going down into the ocean. So the vertical direction is positive upward from the surface into the atmosphere, and the vorticity being put by the winds into the ocean is pointing downward, which means there is negative vorticity being put into the ocean. And remember, we need vorticity conservation, otherwise ocean will keep getting churned faster and faster and faster. So you need to generate positive vorticity somewhere to balance the negative vorticity being put in by the winds. And because the Coriolis increases, it turns out that only place where we can move the mass northward to compensate for the southward transport and to produce positive vorticity to balance the negative vorticity generated by the ocean is on the western side. So we end up creating a narrow western boundary current, which is going to try to push all the water that's coming southward here into a narrow current on the west, and the broad cold water coming down here is the eastward current. So narrow, deep, fast western boundary currents occur in the ocean, both on this side and this side. Broad, shallow, cold currents occur on the eastern side. So the Canary current here, the Benguela current here, the Humboldt or the Peru current here, California current here, and so on are the cold currents, whereas the Brazil current, Gulf Stream, and the Kuroshio in the Pacific are the warm currents that are going northward. It turns out that these warm currents that are taking warm tropical water northward affect these regions very differently in the Atlantic versus the Pacific, which creates the other type of circulation in the ocean that we will look at. Okay, so let's take this kind of a broad introduction, which is very descriptive, but it's good physics, so pay attention to the physics. If we start writing equations again, it gets a little complicated. So just look at the currents now in this case. So you have trade winds pulling the water westward. So you have broad westward current here, south equatorial current, south equatorial current, north equatorial current here, westward, north equatorial current. There are complications in the middle. There is something called equatorial countercurrent here, equatorial countercurrent here. What's happening? As the waters are being pulled westward by the trade winds, southeast and northeast trade winds, the waters can pile up here against the boundaries. When you pile up water, water flows downhill by gravity. So that downhill gravitational flow is producing what is called a counter current. It's called a counter current because it's actually flowing against the winds. So you have a counter current here, you have a counter current here, and you also have a counter current here. But Indian Ocean is complicated because it has reversing winds. Remember, we have southwesterly winds in the summer and northeasterly winds in the winter. So that complicates the situation a little bit here. But here is our favorite gyre, North Pacific gyre, South Pacific gyre going the other way, North Atlantic gyre and South Atlantic gyre being shown here again like this figure we looked at. So trade winds, westerlies, creating the North Atlantic gyre. Similarly, southeast trades, mid-latitude westerlies, creating the South Atlantic gyre. So note that this is going counterclockwise because the anticyclonic circulation in the southern hemisphere is counterclockwise, whereas the anticyclonic circulation in the northern hemisphere is clockwise. What is anticyclonic circulation? It is around high pressure. Why is there high pressure? Because that's the subtropical high where the Hadley cell is sinking, divergence at the surface, high pressure at the surface. So you can see how the ocean and the atmosphere are related to each other. Similarly, there are gyres in the subpolar region. So you have a western boundary current that is coming south here, eastern boundary current going north here, similarly coming south here, going north here, and so on and so forth. So just try to get the idea of how the anticyclonic circulation around the subtropical high gets set up by the trade winds and the mid-latitude westerlies. And the most important thing to remember, again, the western boundary intensification, western boundary current in the ocean, are related to the fact that Coriolis increases with latitude. So you have narrow, deep, strong currents on the west and shallow, broad, cold currents on the east. So you have California current, Peru or Humboldt current, Benguela current, and Canary current here, and Gulf Stream. And so here the western boundary current is reversing seasonally. So you have Somali current going north in the summer, south in the winter. You have the Agulhas current here. And there are several special cases, like the Southern Ocean, which is a channel. So winds can keep on churning the ocean. So you have what is called a circumpolar current. So wind currents can go around and around. And there are many details there that we will not go into. But if you go and look at chapter 8 of my oceanography course, I get into more details there. Okay, so what does this mean? If you look at the eastern boundary current here in Peru, the sorry, this is the Peru current. I don't know. This is Africa. So there's a place called Africa in Peru, I think. So that temperature you can see is much colder than the Rio de Janeiro, almost. In fact, to the south of this place, yet it is very warm because you have a warm western boundary current coming down here. So the Rio de Janeiro temperature is much warmer than Africa, Peru, or Ecuador. I'm not sure. It's a Peru, I think. So cold eastern boundary current, Peru current, makes it very cold compared to the western boundary region of Rio de Janeiro. So you can expect that this is cold, foggy, dry desert region here. This is wet, moist, rainy region over here. Okay, so let me leave it here and then discuss a little bit more about ocean profiles in the next podcast. But those are the things to remember. Oceans have boundaries. Coriolis increases with latitude. This leads to western boundary intensification in the ocean because you are trying to balance water movement, so mass balance and vorticity balance. If you remember that much, you'll be doing well. So if in an interview somebody asks, do you know why there is western boundary intensification, and you say because Coriolis increases with latitude, they will give you a pass. Okay, that's important to remember.